Another idea we want to explore with rational expressions is something called an asymptote. And we're going to find out that rational expressions can either have a vertical asymptote, horizontal asymptote, or an oblique asymptote. What we're going to look at are vertical asymptotes right now. And basically an asymptote is an imaginary line that the graph can't cross through. So let's discover why that might make sense on some of these expressions. We discovered earlier that we want to be careful about what are some values or some domain restrictions. And we see on this first one, this first example, r of x equals x over x squared minus 4. Well, the domain restrictions there, and we look at that in the denominator, are for all x, such as x does not equal plus or minus 2. Well, how that comes over when we graph then is we realize the graph does not have values at those x points. So what I would do then is put in vertical asymptotes. And a lot of times we just designate them by dotted lines. And what that means is I'm graphing it, the graph will approach one of these asymptotes, but won't cross it. It will just get closer and closer and closer and closer to those particular lines. So right now what we're doing is we're just identifying where those vertical asymptotes are at. And then we'll discover later that when we're graphing, we're going to have a line, a graph that's going to kind of approach, and it's going to approach one of those asymptotes, always getting closer but never touching. Let's look at another example. We want to find out where is the vertical asymptote located. On the second example, the denominator is x minus 1. This whole term, it's in lowest terms, I can't factor anything down. So I have right here then a vertical asymptote at the line x equals 1. So I would just put a dotted line on my graph and realize that I have a vertical asymptote there. On the third one, h of x equals x squared over x plus 1. Well, it's in lowest terms. I can't factor it down. And once I can't factor it any farther, I can look at the denominator and find out that I have a vertical asymptote at negative 1. The third one, a little bit different. We realize that maybe I can factor it. So let's first factor it down. X plus 3 times x minus 3 over x plus 3 times x minus 7. I see that I can determine what my domain restrictions are here. My domain restrictions are all x, such that x does not equal a negative 3 or a positive 7. But that doesn't tell me just its vertical asymptotes. I have to go a little bit farther to find its vertical asymptotes. And once I reduce the polynomial or the rational expression all the way down to its lowest terms, so that is just x minus 3 over x minus 7. There, I can determine where its vertical asymptote is. And its vertical asymptote, it has 1, and it's going to be at the point where x minus 7 equals 0, or at the value at x equals 7. 1, 2, 3, 4, 5, 6, 7. And right there, I have a vertical asymptote. And I also have an additional domain restriction as discovered earlier in the problem at the point x equals negative 3. So that's a little bit about vertical asymptotes. And those are going to be very important to us as we start to describe some of these rational functions.